All right, guys, this is page 4. Here's another real world example of exponential growth. The prize for a radio station contest begins with a $100 gift card. Once a day, a name is announced. The person has 15 minutes to call, or the prize increases by 2.5% for the next day. Write an equation to represent the amount the gift card in dollars after T days with known winners. So they told you right there it's a growth, it's increasing. Ask yourself, is it going up or down? This one is going up. You start with the formula. Then, what's the initial amount? $100. What's it going up by? 2.5%. We write that as a decimal. So there you go. Here is the equation you're going to use. Y is the amount of the gift card, and T is the number of days since the contest begins. How much will the gift card be worth if no one wins for 10 days? 10 days, ask yourself, is that the amount the gift card is worth? Or is that the time? That is the time. 10 days. You substitute that in and solve. So after 10 days, the gift card will be worth $128.01. Let's go to the next page. Do one on our own. Oh, there's no guided practice. This is an exponential decay problem. The exponential decay, the original amount decreases by the same percentage over a period of time. It's a variation of the growth equation. So if you look at the decay equation, it's just like the growth equation, except you have a minus there instead of a plus. All the other things mean the same thing. Here is a example. Interpret the parameters of an equation. Phone service. The percentage of an area in the continental United States not covered by cell phone providers can be represented by y equals 0.150 times 0.5 raised to the t power, where t is the number of years after 2012. So t after 2012. And interpret the parameters of the equation. Make a prediction about the future coverage by the service by the provider. So it's pretty much the same thing. Our A is 0.15. We are starting with 15% of the United States is covered by a cell phone. The rate of change, this is where it's tricky, because that 0.45 is 1 minus r. All right? So some number was subtracted from 1 to get 0.45. What is that number? To get that number, let's just solve the simple equation. Subtract 1 from both sides. So negative r is negative 0.55. Divide both sides by negative. R is 0.55. That is 55%. You do not need to go through all these steps. If you can just think it out, ask yourself, I've got a hole. If I took 45% out, what is left? 55% is left. I like to think of money. I have $1. If I paid 45 cents for something, what am I going to have left? 55 cents. So instead of doing all that, there's your percentage, 55%. So the rate of change is 55% per year, and it's a decay. It's going down, going down. And then if this decay rate continues, then the percentage that is not covered by the service provider will drop to about 0.1% by 2018. How did we get that? It's since 2012. So 2012 to 2018 is t equals 6. So you make t equal to 6. And you will plug that in. So you look at Desmos. Here it is, 0.15. That's your A, 0.45. Now this is another way you can tell it's a decay problem. B is less than 1 but greater than 0. That's just if you just had the formula, you would know it was a decay based on the formula. Okay, so if we were to graph this, there it is. Our y-intercept should be at about 0.15 from what we learned the other day. It's going down at 0.45. Now, how many years did we say? T equals 6. We just T equals 6. We can graph it if you want. You want to do x equals 6 and do it by graph? Or you can just plug 6 in there. There's T equals 6. Point 001. That is our answer, I think. So let's put a 6 there. I am. Oh, you can't see it. 0.001. Now remember, that's a decimal. 0.001, if you want that as a percent, times it by 100, or move your decimal 2 spaces, that's where they got the 0.1% from. 0.1% by 2018. Let's go ahead and do the guided practice on this one instead of starting a new video. Tuition, that is how much you pay to go to college or trade school or private, even high school. You would pay tuition. A college's tuition has risen 5% per year. That word right there, risen. Are we going to do a growth or a decay? Growth, decay, risen, growth. So we're going to be doing a growth problem. Since 2010, if the tuition in 2010 was 10,850, that is our starting point, A. Write an equation for the amount the tuition will be in 10 T years after 2010. So how much was it going up? 5%. So remember 1 plus 0.05 T. All right. And then predict the cost tuition in 2025. 2010 was our starting point. So how many years between 2025 and 2010? Subtract. I think that's 15 years. So T is going to equal 15. Let's put this in Desmos. All right, I have my equation written in Desmos here. And recall we wanted it after 15 years. So what we can do is take our x here and make it 15. It is going to be $22,556. So you can type that in the box here. You have this big old box just to type in that simple little answer. So our tuition, how about we do a sentence? The tuition after 15 years will be approximately, so about $22,556. $22,556. Ooh, is that almost double? Yeah, that's about double. Great job, guys. So, how do you feel about these? Yeah? Hmm? Hmm? All right, you just gotta put it in the formula, think about it. You got this. I know you do. Good job, guys.